All right, so now we're ready for the formula writing section. I'm going to remind you of the notes I gave you in class. Today's it would have been Tuesday. So we said that when you're naming compounds, if you see a name that ends in ATE or ITE, that means it's going to have a polyatomic ion in it. So let's just take a quick look here. There's one, polyatomic ion. That's not. There's one that has polyatomic ion. So you know on those compounds, you're going to look at the bottom of your table to find the second part. Then we said the IDE ending contains two elements, and they end in a plain element with these exceptions. And that was hydroxide and cyanide and peroxide. They end in IDE, but they're polyatomic ions, and you just have to remember that. So let's look at them. That one is phosphide, and it's not one of these three exceptions, so that's going to be a plain old P. Bismuth oxide, that's going to be a plain old oxygen because that's not one of these three exceptions, so just be a plain old O. Lead 4 hydroxide, oops, that ends in IDE, but it's one of these exceptions. So hydroxide, its polyatomic ion is going to be OH. All right. That oxide up there, that's just a plain O also. So there we go, plain O, oxide. Okay, then it also says that in formulas, the positive charge and the negative charge have to be equal. So now we're going to find the rest of the symbols, make the charges equal, and then we'll be finished with this little practice final. Okay, so first of all, on aluminum sulfite, we know the symbol for aluminum is Al. And sulfite, we have to look down here and find it, and sulfite's SO3 with a -2 charge. So SO3, -2. Aluminum, it's got 3 valence electrons. The general rule is 4 or less. They lose electrons down to 0. 5 or more, they gain electrons to 8. Lose to 0, gain to 8. So aluminum has 3, it's going to lose because it's 4 or less, so it's going to be a +3 charge. So now you need a common multiple of 2 and 3. If you did the bonus sticky note activity, you would know you would need 2 sticky notes of this and 3 sticky notes of that. To show the 3 sticky notes, you have to put parentheses in like that and a 3 outside the parentheses. The 2 can go in or out, doesn't make any difference because really that's not part of your formula. You just have to think about it. Okay, this one's aluminum phosphate, so we find aluminum's again, the same one, so just put that down. Phosphate is down here, and you got to watch it because there's a phosphate, there's a hydrogen phosphate, there's a dihydrogen phosphate. You want just a plain phosphate, so that's PO4, and it has a -3 charge. Oh look, they're already even, so you don't have to do anything else on that one. You don't need parentheses because there's not more than one of the polyatomic ions like there was over here. All right, lead 2 permanganate, so lead is Pb, and the 2 tells you that the charge is +2. That's convenient, you don't have to look it up. Permanganate is another ATE polyatomic ion, so you come down here, MnO4 -1. Well, if that's a 2 and that's a 1, we have to make the charges equal, so you're going to put parentheses and a 2. All right, now tin-4 oxide. I always joke tin-4 is popular with truck drivers, but you might not get that one. So anyway, tin-4's SN's got a +4 charge. That's convenient because that's a 4. Be sure you realize that's a 4, not a 5. So that's +4. And I've already written the oxygen down. I forgot about that, so I'll put it up here. That's a -2. We know oxygen's a -2 for a couple of reasons. It's got 6 valence electrons. The rule was if there's 5 or more, they gain to get to 8. So from 6 to 8, that's 2. Also, if you look closely, it'll tell you it's -2 because it says right there in the corner -2. All right, so if you have a 4 and you have a 2, how many 2s do you need? You need 2 2s, which I guess is appropriate for a dance school. All right, sodium phosphide. So we have sodium, that's Na, and phosphide is P. So P is over here with 5 valence electrons, so it's going to gain 3. Sodium's over here with 1, it's going to lose 1. So that's a +1, that's a -3. The charges need to be equal, so I need to multiply 1 by 3. If we were doing sticky notes, you'd have 3 sticky notes of Na and 1 sticky note of P. bismuth 3 oxide. So bismuth is Bi, and the 3 tells you the charge, which is convenient. We already know that the oxygen's -2, so we need a common multiple of 3 and 2. So how many 3's do you need to make 6, which would be the least common multiple of 3 and 2? How many 3's do you need? You need 2 of them. How many 2's do you need? 2 times what equals 6? And that's your formula. Okay, lead 4 hydroxide. So we have lead is Pb, and that 4 tells you the charge is +4. Hydroxide is that one that we said was a polyatomic ion that you just had to remember was a polyatomic ion. So you go down to the bottom here, and you see this OH, hydroxide OH -1, has a -1 charge. All right, so how many 1's do you need to match a 4? If these were sticky notes, you'd have a Pb sticky note, then you have an OH, and you'd have another OH, and you have another OH, and you have another OH, because each one of those is -1. So it takes 1, 2, 3, 4 of them to match that. So to show this in a formula form, you'd put a 4 down here, but since that's a polyatomic ion, you have to have parentheses because we need 4 of both the O and the H. And if you put the 4 just after the H with no parentheses, it looks like it only applies to the H. You need it to apply to everything, so you use the parentheses. All right, so that's the formula writing section. We have Monday for questions, so come prepared, and I'll answer questions for whatever you need to ask.